Okay, students, now we're doing 8.4. This is the last section of our functions unit. Then we'll do a review and take a test. Okay, so review again. We have these two symbols, meaning absolute value, ABS for absolute value. Okay, and we've talked about the definition of absolute value. Hopefully you've already reviewed it in your head right now. The distance from zero. And what do you know about distance? It is always what? Distance is always positive. Okay, so that means you better get a positive answer when you're done. So how far is negative 12 from 0? It's 12. How far is 12 from 0? It's 12. Okay, then we have square roots. The square root of 16, we've done that. This is 4. Okay, what times what equals 16? Now, you won't see this till algebra 2 when I have a negative underneath the square root. That's called an imaginary number. So we're not dealing with that here. So if they gave you that, they would probably identify that as non-real. Okay, the numbers are either real or imaginary, or it's a combination of both called complex. You won't get into that till algebra 2. So that's technically imaginary, but they also might just say it's non-real. Okay, because up through geometry, you'll just talk about real numbers, not non-real. All right, so how about the graphs of these functions? I've talked about this before. An absolute value graph graphs into a V. And we'll see that here. We do an X, Y, T chart, graphs into a V that opens up or down. Okay, I'm just going to put one there. And we talked about what a square root graph looks like. That general shape looks like that right there, starting at 0, 0. And this is before any shifts. Okay, another unit will be doing the shifts of the functions. You're just doing the basic functions right now. Another chapter will be doing shifts with them. Okay, so we can easily fill this in. The absolute value of negative 2 is 2, 1 is 1, 0, 0, 1 is 1, and 2 is 2. And now you could plot those points. You've got 0, 0, negative 1, 1, 1, 1, negative 2, 2, and 2, 2. And you'd see that they just look like that. Notice this is a slope of 1, and this is a slope of negative 1. Just as reminders of slopes. Okay. Since we just got done talking about piecewise functions, we could actually graph those by pieces, saying our equation, if I was to do that, our equation would be negative x for x less than or equal to 0, and be positive x for x greater than 0, or you could say greater than or equal to 0. That would graph that v. Speaking of piecewise functions, so there's two pieces there. But the graphing calculator knows the absolute value function, and it'll graph it all at one time for you. But I just want to quickly review piecewise functions right there if you wanted to put it into pieces. Okay. Or you forgot how to get to the absolute value function on your calculator. Okay, but you remember how to do your piecewise functions. All right, the square root graph, we know. Now, when I pick square roots, I want to pick perfect squares, so I get nice numbers. So the square root of 1 is 1. The square root of 4 is 2. The square root of 9 is 3. Okay, the square root of 0 is 0. Okay, so here I'd have 0, 0, 1, 1, 4, 2, and 9, 3. So you see that general shape, and it will just keep going up towards infinity there. Okay, when you just have this with no plus or minuses with the x's inside or outside, those are called parent functions, just so you know. So make sure you're familiar with that. Okay, so we have, now the question says, where does the absolute value graph, where does the absolute value of x equal the absolute, or the square root of x? So where did those two graphs intersect? They intersected at 0 and at 1. Okay, x equals 0, right where they both started from, and x equals 1. They both are at 1, 1. Those are the only 2 points. Okay, now let's see. So I just showed you through an XYT chart, because you can always make XYT charts of any of these. Okay, now let's see. And then remember x squared graph. So there's that graph we just did. Remember, x squared graph is a parabola. Let's change that color. And so if I did that, here, let's just make another XY T chart. So x and x squared. Okay, I could have put that down here. All right, 1, 1, negative 1, 1, 2, 4, and negative 2, 4. So and 0, 0. Okay, so 0, 0, 1, 1, negative 1, 1, negative 2, 4, and 2, 4, for example. And so this would look like that right there for that x squared graph, parabola. Okay, so those are our 3 main ones in this section that we're dealing with here. So we can look at the graphs of the functions. Remember, that means it passes the vertical line test, or you can say for every x there's only one y. You can also say therefore there's no repeat x's. Okay, you can have repeat y's, you just can't have repeat x's. Remember, when you label the domain and range, you only name each of the domain once, the x coordinates, and each of the y coordinates called the range once, no repeats. That's review of the prior couple of sections that we talked about. Okay, we just talked about the shapes of those graphs. We just drew them right there. Now, what we're going to focus on in this section is how to type things in the graphing calculator and actually get the solution from the graphing calculator. Okay, so you might not have been taught this before. Now you're going to learn it. So, of course, we want you to be able to solve it by hand, solve them by x by hand. We subtract the 2x across, because we want the smaller variable to go into the bigger side, which means the constant's coming over here. So we subtract the 3, and we get x equals negative 10 minus 3 is negative 13. That's where it's going to intersect at x equals negative 13. Okay, and so that's the answer. We're going to see how you can get that answer on the graphing calculator. So you can check all of your answers when you have solving for x equations. We're going to practice typing these in the graphing calculator right now and get the solution. I just showed you right there a quick review of doing it by hand. Okay, so x equals negative 13. Okay, that's by hand. But we're going to show you how you can type these in the graphing calculator and get that answer of x equals negative 13. Now, that doesn't mean you can do it on your test, okay, unless it says solve it by the graphing calculator. Then you can do it on your test. Otherwise, you have to show the steps normally like you did have already in the past since 6th grade on, 7th grade on. Okay, show all your steps. Okay, so that's what we're practicing here. As it says, solve the equations by graphing the functions. So you don't even have to know what they look like, okay, and do all the algebra stuff. And it says round to the nearest hundredth if necessary. What that means, if it says if necessary, that means if it doesn't come out to be an integer already. Obviously, if it came out to be like negative 1, 4, you don't have to round to the nearest thousandths, it's done. But if it didn't come out to nice integers like that, had all these decimals, then we're going to round to the nearest hundredth. That's what it means when it says if necessary. Okay, so let's go ahead and practice seeing these. And what these graphs are here for is it wants you to go ahead and then plot the general shape of what you see on your graphing calculator screen there, but you're just going to go ahead and put the answer itself down here. Okay. So let's go ahead and get started and type these in. Okay, so what you do on the left side equal sign, you type in what you see. Okay, so let me move this over here more so we can see our equations. Here, we'll go to this side for this one. So on the left side equal sign, I type in 2x minus 10. Hit enter. Now on the y sub 2, I put what's on the right side equal sign, 3x plus 3. Enter. Okay, then I'm going to hit graph. Notice how I don't see where they intersect. These are what the two lines are. So I don't see where they intersect. Before I can have it calculate that point of intersection, okay, and solve for it, I need to go ahead and I can do it one of two ways. I can hit zoom and then go to number 3, zoom out. I can hit number 3 or just scroll down and hit zoom out. It's going to put the cursor there. Where does it want it to zoom out? I can just hit enter again. And now notice down here, I can go ahead and see that point of intersection down here. If I can see that point of intersection, then I can go ahead and solve it. Okay, if not, I have to change my window. The window is right there. So notice it went from negative 40 to 40 on the X and from negative 40 to 40 on the Y coordinates. By default, it's negative 10 to 10 and negative 10 to 10. To always go back to the default one, you just hit zoom 6. That's the standard one. So if I hit that right now, and now hit enter. Oops, he's not doing it. Quit. Zoom 6. There we go. Okay, so now it's back to the standard one. Again, I can't see it. So notice the window, negative 10 to 10, negative 10 to 10. Okay, I need to zoom out 3. Now I can see the point of intersection. Now I'm going to go ahead. I want to calculate where they intersect. So second, calc. I hit number 5, intersect. Hit enter 3 times. 1, 2, 3. And there's your answer, negative 13. Okay, you can do this for any equations that just have one variable, x in it, for example, or one variable throughout. You know, it doesn't matter if it's x or s's or t's, as long as it's only one variable. Okay, so let's go ahead and go to the next one. So we want to clear this out. Just hit clear, go down, hit clear. Okay, let's try the next one over here. Notice this 2x plus 4 all divided by 5. Now remember, since there's more than one term in that numerator, I need to put parentheses around that. 2x plus 4 parentheses divided by 5. That's in one equation. I put that in y sub 2, so that means the 12 on the other side is going to go in y sub 1. Okay. Hit graph. I can see the intersection, so I don't have to zoom out at all. So I can go right to second, calc, number 5. And I need to move it up so I can see. Enter, enter, enter. And so if I was to solve that for x, I'm going to get x equals 28. Okay, there's my answer. So if I was to do that by hand, just to check that, remember, opposite of division is multiplication. So I'm going to divide by 5 on both sides. Cancel that out. I get 2x plus 4 equals 60. Subtract the 4 across. 2x equals 56. And last step, divide by 2, and you get 28, just as we saw on the graphing calculator. So you can check all your answers now. Okay. So you can know if you have them right by typing in the graphing calculator like this before you turn in any quiz or test. Okay, as long as graphing calculators are used, allowed to be used on it. Okay, you can't just have the answer of 28 and have no work. You get no credit unless it's said to solve by the graphing calculator, such as these right here. It says solve by the graphing calculator. So if I'm going to give it to you on the graphing calculator, I'm going to give you one of these tougher types, like number 3, that you're not going to solve that by hand at all. You need to use the graphing calculator. Okay, so let's do one more as an example. We've already done example 4 above. Okay, and then we'll actually write in the general graph right there in that box. But ultimately, what I'm caring about is the solution. In this case, rounded to the nearest hundredth. Okay, so x plus 12 quantity squared equals 2 absolute value of x. Here we go. Go back to my y equals, clear that one, parentheses, x plus 12 quantity squared equaled 2. Now absolute value, I can hit second 0 for catalog, and the very first word is absolute value. Just hit enter. It's going to put the absolute value in there, and we just want it of x is all it said. Now I have to right arrow to get outside of there. Hit enter and move down. Remember, see again, these two equal signs are darkened. That means it's going to graph both of them on the same axis. So hit graph, and we can see the 2 points of intersection. We have a parabola, and we have our absolute value graph. Remember, absolute values are v. And then we had a parabola. So here, quadratic, degree 2 right there. So that tells me it's going to be a parabola. And what happens when it says plus 12 inside that parentheses, it means shift that x squared graph to the left 12. You're always doing the opposite operation. We're going to get into that when we talk about shifts. Remember, we haven't talked about that yet. Okay, and then there's 2 in front of the absolute value, the normal v. You normally have your normal v. Well, this says take that v and times each of those y values by 2. So that's going to make it a little narrower v is what it's doing. Okay, so again, we can see both the intersection points. So we want to now go ahead and find them. Second calc, number 5. Intersect. First curve, second curve. Now the guess, the first time through, I can just hit it 3 times. It's going to take me to the closest answer of where they intersect. Notice that's -8. So -8 is one answer. Now I'm going to do second calc again, number 5. Enter, enter. And now my guess, I need to move it closer to the other answer. Now it's closest to that answer, so now I can hit enter, and I'll jump to that next closest answer, -18. So my 2 answers are -8 and -18. Notice it's only the x coordinate that I'm using for my answer. Okay, so -8 and -18 would be my 2 answers. And then I go ahead and graph that parabola in there and graph a v in there. So if I go back and draw that here, I'm going to have that parabola that you just saw on the screen like that, and you've got your v, okay, like that. And so these are the 2 points that we found. We found -8 and -18 were those 2 points. And so you can just put a point there and put a dot there. If you want a dot there showing that's my point of intersection. Okay, you just kind of have a general shape of the curve of the graphs inside of that right there. Now notice I only had to put down -8, -18 because they came out to nice integers. They weren't decimals. If they were decimals, I'd round to nearest thousandth. Now you remember the thousandth spot, 2.1, let's say it's 5, 6, 7, 8, 9. Okay, tenths. Hundredths. Remember, they're all in the THS. Thousandths. So since we're at the nearest thousandths, I look at the next number over, past it. If it's 5 or higher, I round up. You should know this all the way back from elementary school. So my final answer in that case would be 2.157. Since that's a 5 or higher, that 6 goes up to a 7. So when it says thousand spot, I have to have out to the thousands. Oh, we wanted hundreds. Okay, well, I just practiced thousands. Okay, so those practicing if it's thousands. Okay, if we want the hundreds, we're only going out to here. I was thinking thousands because that's what calculus does. Calculus, they go out to the thousand spot all the time. Here, okay, hundreds. So I look at this one instead, the next one over. Is that 5 or higher? Yes, it is. So I'm going to round up. So it's going to be 2.16. That's the 100th spot. You got to have the number in the 100th spot. These other numbers do not matter. If I'm going for the 100th spot, it's only the one next to it, which is the 1000th spot. That's the one I'm looking at. So don't think, oh, this 7 rounds this one up, and then I use that. No, you're not using any of these numbers. You're only using the one number to the right of what place value you want, right there. Okay, and that should cover everything, because I think the whole assignment practically is doing this right here. Just typing in a calculator, you're getting to practice. Yep, typing these in the calculator. Square root function. Okay, let's just do number 5. One more. So you can see on your graphing calculator, I'll show you where that square root function is. So we'll do number 5 at our last one. Here, down here, you have review of functions that you can type in, okay, where they're located, okay. As I show them on the calculator, if you forget, you can go back to this video, or you see right here in your packet. It's got it right there. All right, so I'll do one more, number 5. Let me write this down so I don't have to keep flipping back and forth what the equation is. 3x cubed minus 12x minus 6 equals negative square root of x plus 5 and then minus 8. Okay, last one, because this is all you're doing for the assignment. Then you have review problems from earlier in the year. Okay, go back to y equals, again, clear out. Okay, we type it in 3x. Now I want cubed. Remember, this is only the squared one. So I'm going to use this caret symbol right here, and it puts it up in the exponent, and I hit the 3. Now I have to hit the right arrow to bring it down. Minus 12x minus 6. I have to use the negative symbol. Now the square root is right there. See, it's the blue one above the x squared. So second x squared x plus 5 and then minus 8. I hit graph, and there it is right there. Now notice I look at my window, it's all at negative 40, 40. So let's hit zoom 6, get back to the standard window. Okay, now that looks nicer, but I can't see the red, so we're going to lower the y values past negative 10. Let's drop the y minimum down to, say, negative 25. Now hit graph. Okay, now you see that nicer right there. That's how you can adjust. So I didn't have to hit zoom out. That's another way. All I do is just lower the y. So I just went to the window and lowered the y minimum. Okay. So we have the graph. So you go ahead and graph that. I'm not going to graph it on your screen. Okay. You just put this in the box on the screen. Key is then you're finding the intersection point. So I got 1, 2, 3 points of intersection here. Okay, so I got to find all 3 of them. Number 5. First curve, second curve, guess. So the first one, let's do that. I didn't see where it jumped to. Number 5. Which one is that? Okay, there it is right there. Now I can see it blinking. 0.373 when you're, oh, we're going to nearest hundredth only, not thousandth again. 0.37, because the next one is a 2, right? So we'd have 0.37. It's one solution. Next. If we wanted these as points, okay, I'd have 0.37 comma negative 10.3. 2, since we're on the nearest hundredth. Okay. So next one. So I got that one, so I need to get that one and that one. Second calc, number 5. First curve, second curve, there's only 2 curves in another guess. I need to move it closer to one of the ones I want. I want that one right now, so I'm moving it closer to it, hit enter. And I get negative 2.14 because of 3, 8. 8 rounds it up to 4. And now I do it again. Number 5. And curve now for the guess, I got to move it all the way over. Hit that right there, and I get 1.770, so it'll be 1.77. Okay. So these ones you would not be able to like graph by hand and all that kind of stuff. So you put in the calculator to get your values. Okay, your X values of doing the calculations. So you would graph that, and then, like I said, I'll just write up those numbers there that I said out loud. Okay, we had 0.37, we had negative 2.14, and we had 1.77. Okay, so if you want to check it yourself, plug it in and make sure you come up with those values. You have those values written on the screen right there. Okay. And so that's what you're doing. You're practicing putting equations into the graphing calculator and coming up with their solutions. Okay. One thing that also helps to note, I look at the highest degree of the equation there. Notice it's the highest degree is 3. That means there should be 3 answers. Notice you came up with 3 answers. Sometimes there's going to be repeat answers, but there should be a total of 3. Okay. So the highest exponent usually tells you. So when I go and do x times that x there, I get x squared. That's going to be the highest one. So I should end up with 2 answers on that one. Okay. So that's called the degree of the equation. It usually tells you how many answers there are. Okay, even if they're repeat answers. All right, that goes ahead and ends this video.